Good afternoon, evening, or morning, lovelies. It's good to see you all. The world we live in is ever-changing, and the weather definitely reflects that. Yesterday I went out and it was snowing, and the next day, it was really hot and sunny and I was wearing flip-flops and shorts. So, let's take a deep dive into this, and let's see what kind of weather we have in store for us now.
In the United States alone, weather forecasting is a $17 billion industry.
I'm sorry, what?
$17 billion.
You're telling me that the weather people who don't always get things right, 90% of the time are wrong, whose apps we look and go, whose unreliable weather app is closest, are paid how much?
I don't know how much they're paid, but they spend $17 billion. Split between private companies and government agencies. To put it in perspective, we spend $150 billion a year on our pets. This makes sense since we probably like our pets a lot more than we like the weather. Most people check the weather every morning so we know what to wear for the day. If the weather is extremely unpleasant, it will be discussed around the water cooler, but always with a sense of resignation. There is nothing we can do about it except complain when it disrupts our plans. But what if the weather could be fascinating? What if, instead of complaining about the weather to your coworker, you could discuss how amazing it is that we have a global system that creates weather that gives us an environment perfect for life?
But Jen,
What?
I enjoy complaining.
Everybody loves to complain about the weather.
I mean, the weather is the safest topic to complain about. It's just the weather. The weather is droopy out. Gosh darn it. Look at the suntan I got because the sun suddenly started going 50 miles an hour like the Flash. The weather is the safest topic to complain about. How dare you take that away from me?
I promise you, everyone is complaining about it. We are unified in our complaining about the weather. What do we mean by weather? Weather describes the current state of the atmosphere in one area. It is influenced by temperature, air pressure, wind, humidity, and rain. The shape of the continents also influences it, but we'll talk about that in another series. Do not get me started on Pangea. Did you catch that? Temperature influences the weather. That may seem obvious, but we often get it backwards. We think it is windy out, which makes it cold, but actually it is windy out because it is cold. Temperature does not cause weather, but it helps create the conditions for it to occur. As an aside, the weather is extremely difficult to figure out, which is why forecasts are often inaccurate. I am going to discuss one part of the weather, temperature. Just know that while temperature is vital, many other processes also influence the weather. Weather forecasters talk a lot about high and low pressure systems. They stand in front of a green screen and wave their arms, describing how the high pressure system will swoop this way, bringing warm weather, while a low pressure system brings cold and rain. What are they talking about? High and low pressure relates to air pressure in an area. Go outside and look up. You may see clouds or the sun, but what you don't see is the air. However, the air in the atmosphere is heavy. It is currently pushing down on us at 14.7 pounds per square inch. We don't feel it because we were born on Earth, and it is all we know. Still, that is a lot of air pressure. However, due to temperature and air density, pressure is not uniform on Earth's surface. This is what we call high and low pressure systems. Low pressure systems mean the center of the system has lower pressure than the surrounding area. The low pressure is cooler than its surroundings. High pressure systems have a center under higher pressure than the surrounding area. Thus, the temperature of the center will be higher than the outside. I know you all remember the second law of thermodynamics from our Kelvin episode.
No, we don't.
Well, you should. It was really important.
Absolutely not. If you ask me to look it up or go back, I will have it probably in a notebook somewhere, but that is not, in fact, an index card in my mind.
Okay, everyone go back and listen to session 4, and then come and start up here again, okay? There we go. Or, I'll just remind you.
Yes, that one. Do that one.
Heat flows toward cold. That means high pressure areas flow into low pressure areas. When the center of a system has low pressure, the surrounding higher pressure air will move toward it, forcing the cold air to rise into the atmosphere. As the air gets colder, water vapor condenses, causing rain. Using the same idea that heat flows to cold, if there is a high pressure system, it will flow outward toward the low pressure area. This brings cooler air down to the surface along with blue skies and sunny weather. It all depends on the temperature. Meteorologists use a handy equation called the ideal gas law to figure out what the atmosphere is doing. I won't share the equation here, although it is not even remotely evil. What is fascinating is that the temperature unit in the equation is in Kelvin, the temperature scale used in science. Cool.
It's a science law. Why wouldn't they use the science temperature? Also, why does this law thingy you mentioned above sound like something I'd have in like a hot tub area?
The ideal gas law?
You know where Yellowstone is? All those geysers? I feel like that's the perfect place.
Well, I bet this law works for lots of different gases, but when they're using it in weather, the gas they're measuring is air.
Air is technically a gas. It is not solid, it is not liquid.
That is correct. We don't think about it as a gas, but air is a gas, and so that's the gas that they are measuring. There are many other ways temperature influences the weather, but I want to talk about some specific examples. Since I currently live in Arizona, let's start with hot weather. I live in Arizona now and have lived with extremely hot weather, usually in the summer. In March 2026, the West experienced a heat dome, which is when unusually high temperatures persist over a large area. This heat wave affected more than 14 states and broke records for high temperatures. So how does a heat dome differ from a heat wave?
One of them plays football and the other one surfs.
I assume the heat wave is the surfer?
Well, you would assume right. A heat wave is like a wave. It goes whoop, whoop, and it goes through the thing and passes through. A dome is like when you're in a football stadium. The players run back and forth, and they don't leave quickly.
There you go. Heat waves are local events lasting a few days, during which temperatures spike and then return to normal. Normal for Arizona might still be in the low hundreds. A heat wave could bring temperatures up to 118 or higher, but not for very long. Heat domes look at heat waves and say, "Hold my beer." Temperatures will get hotter and the affected area will grow to as much as 1,000 miles. Heat domes are self-feeding systems, so it takes a major change to end them. Remember the high-pressure systems we discussed earlier? That is what a heat dome is. High-pressure systems are hot in the center and cooler along the edges. Hot flows to cold, so the hot air from the middle flows outward along the Earth's surface. As it does, air from above sinks down to fill in the center. If the air is cooler, the high-pressure system will bring picnic weather. But if the air that fills the center is warmer, it feeds the high-pressure system, creating a dome of heat over the area. The hot air from the center continues to flow to the edges, and more hot air fills in. The dome grows, and temperatures remain high for longer periods. Heat domes end when cooler air breaks through the system. This does happen eventually, but the dome deflects much of the weather, sending it around the system and affecting the area outside of the dome. Heat domes' wetter cousin is hurricanes. Heat domes are high-pressure systems that bring heat down, whereas hurricanes are caused by low-pressure systems that bring warm, humid, tropical air up into the cooler atmosphere, where it condenses and creates rain. If this cycle continues long enough, hurricanes are born. These large weather events go by many names. In the Atlantic and Pacific Oceans surrounding North America, they are called hurricanes, the name I use most often. In the South Pacific and Indian Oceans, they are called cyclones. In the western North Pacific, people living in the Philippines, Japan, and China call them typhoons. Overall, they are tropical cyclones. A hurricane by any name will still cause great destruction. These low-pressure events do not become hurricanes until they have wind speeds of 74 miles per hour. The wind is necessary to cause the storm to rotate. This rotation is why hurricanes move from tropical oceans to dry land. It is the dry land that causes its destruction. Once no more warm, humid air can rise through the low-pressure system, the hurricane loses its fuel and peters out, but not before causing damage over a large area. While hurricanes get named and make the news, heat domes kill more people than any other type of weather. I think this is because of the boiling frog effect. When you put a frog in boiling water, it jumps out. But if you put it in cold water and then turn up the temperature, it will boil to death without ever hopping out. I assume this is metaphorical and no frogs were harmed in the creating of this analogy, but it is apt. We can see hurricanes approaching land and try to predict where they will hit. This gives us time to jump out of the hot water, either by evacuating or by preparing our homes to withstand the storm. For this reason, hurricanes destroy more buildings and infrastructure, but heat kills more people. 50% of the world's population lives in the tropical regions north and south of the equator. Many of these people are used to hot weather, like everyone living here in Arizona.
You live in Arizona and you're definitely not heat resistant yet.
I will never be heat resistant. I will be the frog that will want to get out as soon as possible.
So we have to put you in a freezer first?
That would be nice. Let me tell you, I want to crawl in the refrigerator some days, for sure. When an extreme heat event like a heat dome happens, many people figure they will be fine without making any changes. This decision to do nothing can be deadly. Let's travel from where I live in Arizona to where Maddy lives in Montana, where cold can be just as dangerous. Blizzards are extreme winter storms with winds exceeding 35 miles per hour and visibility less than a quarter mile. This lack of visibility can be caused by snowfall or by wind picking up snow from the ground and blowing it around. This is called a ground blizzard. To get enough snow for a blizzard to form, two areas have to be cold enough. The atmosphere needs to be cold enough for condensed water to turn into snowflakes, and the surface air needs to be cold enough for the snowflakes to accumulate. If it is too warm, the snowflakes can turn into rain or sleet. Blizzards often happen at the edge of storm fronts where a low-pressure system meets a high-pressure system. This difference between hot and cold air causes the winds necessary for a snowstorm to become a blizzard. One of the biggest hazards of blizzards is whiteouts. I have only driven in whiteout conditions one time. It was the night before my time off and I was determined to get home. Luckily, I was on a rural highway and not an interstate. It would not be accurate to say I drove in it. Visibility was maybe 20 feet and all I could do was pull over and put my hazards on. Not being able to see the road at all was frightening. Luckily for me, the whiteout was localized and subsided enough that I could continue home. If conditions are not cold enough for snow, an ice storm may form. Freezing rain happens when the upper atmosphere warms, so rain, not snow, forms. As this rain falls to earth, it passes through air that is below freezing. The rain is supercooled, meaning it is cold but remains liquid, not ice or snow. If the Earth's surface is below freezing, the supercooled rain freezes on contact. Ice storms commonly break tree limbs and power lines, causing long-term power outages. Even scarier than having no power is driving on black ice. When supercooled rain hits a frozen road, the ice formed can be clear rather than white. Drivers can see the blacktop below and have no idea how slippery it is until they are driving on it, but then it is too late. When I was a child, I'd never heard of a polar vortex, but now it seems to be a common winter event affecting large areas with unusually low temperatures. The curious thing about polar vortexes is that they are always there. It is only when they become unstable that we notice them. The polar vortex is a band of wind that circles the North Pole 10 to 30 miles above the Earth's surface, sort of like a halo around the top of the planet. Most of the time, it is stable and does not move. During this time, the polar jet stream, winds that blow closer to the Earth than the polar vortex, stay close to the Arctic, keeping cold air in the north. Some years, the polar vortex weakens and interacts with the polar jet stream. This causes the jet stream to move southward, bringing unusually cold temperatures to a large area, which TV weathermen call an Arctic blast or a deep trough.
Wait, deep trough? Like the thing that farm animals eat from?
Exactly. If you look at it on the weather map, it looks like a wave, and so the bottom of waves are called troughs. And so you'll get it like it'll dip down, into Arkansas or something.
The bottom of the wave is a trough. You know what else is a trough? what we use to feed livestock.
I'm willing to bet that a lot of weathermen started out as farmers. It's probably what they can relate to.
They probably saw it and went, that looks like a trough.
That's right, and that's what we're going to call it. And all these city folk was like, what's a trough? Heat domes are caused by hot temperatures and polar vortexes are caused by cold weather, but one of the most destructive weather phenomena is caused by both. Tornadoes are the Hoover vacuums of nature, causing destruction wherever they go. They happen around the world every year, but about 75% occur in the central United States in a region called Tornado Alley. How tornadoes are created is not entirely understood. Tornadoes come from supercells. These are rotating thunderstorms with a strong circulation called a mesocyclone. However, not all supercells cause tornadoes. They can also produce dangerous hailstorms and severe winds that do not rotate like tornadoes, but can still cause damage. I have only been tornado chasing once, and we were much more concerned about the hailstorms we encountered than the tornadoes that we rarely saw.
You went tornado chasing?
Through Nebraska and Kansas in 2011, and it was a big year for tornadoes. Matter of fact, we camped right on the border between Nebraska and Kansas. I think that's right. Anyway, and about 50 miles from where we camped, a town of Hallam, Nebraska was wiped off the map by a tornado that happened overnight. And we were pretty close. We were within 50 miles. But we spent 2 whole days tornado chasing. We saw one tornado, and it was a long ways away. We were up on a bluff. My husband was really into tornado chasing.
You didn't die, so I would say it was pretty successful.
To get the rotation necessary to form a tornado, regional weather temperatures need to be right. Remember, we need the air to rotate. Rotating air is wind, and wind is created when hot air flows toward cold, forcing the cold air to move and allowing more hot air to flow. Once the air is moving, there is wind, and when the wind is circular, it can possibly form tornadoes. The hot and cold areas in the United States come from 3 regions. Cold air travels down from the Arctic, warm air comes from the dry southwest, and moist warm air comes up from the Gulf of Mexico. This magical mixture provides both hot and cold air that can rotate and the moisture necessary to make the supercells the incubators of tornadoes. This is a simplified explanation of tornado formation. Some tornadoes do not require wind rotation to form, and others occur in areas with high winds but no cold air. Dust devils are like this. All the air is hot, but the air at ground level is hotter than the air above it. Hot flows to cold, so the hot air rushes up, bringing sand and soil with it. To better predict the weather and understand the causes of extreme weather, more advanced technology is needed, and older methods need to be improved. One reason that it is difficult to forecast the weather is there are so many variables. We have only talked about temperature in this session, but air pressure, humidity, wind, and amounts and types of clouds can affect the weather in unexpected ways. One way to deal with this huge amount of data is to use AI. AI can use data more effectively than humans, so weather models can be more accurate, improving forecasts and potentially saving lives. To collect all this data, satellites and additional ground sensors can provide the information needed to improve accuracy. Weather forecasting may never be completely accurate because the system changes quickly, but it can be improved. If humans are going to continue to live in extreme heat and cold, we need data and better analysis to improve life for everyone.
I'm interested to see how temperature will affect the different kinds of clothes we make, what kind of new weather phenomenons might happen as the weather vastly changes, and all that fun stuff. What do you guys think will happen in the next 10 or 20 years? I'm interested to find out. Well, nonetheless, I look forward to seeing you all in the last session. Bye-bye!